Yes, I can hear you.
Okay, great, thanks. Right, so we'll start with the last part of today's presentation is top 10 reasons for curb ramp failures. ODOT in the last 2-3 years been working on constructing ADA ramps, and they found a good percentage of them failing, and then they categorized these failures into a few categories. So hopefully we could learn from them, and then we can work on making not happen again. The first one, we talked about the drop-off, and similar to the concept of the standard drawing we talked about, here's what making this ramp failure basically is this concrete surface, the hard surface. In the standard drawing we talked about earlier before the break, if this was soft surface, then that would be okay, especially similarly here. The reason is a person could be wandering here and they could come up drop off here. So that is one of the reasons for a drop off if this type of configuration Y is failing. Similarly here, person could be maybe wandering here and filling up here. So I know there are on Market Street in Salem, they're under I-5 ramp. There are a few of this intersection, and after the fact, I think after the design order came up with those candlesticks here, so preventing people coming around and as a remedy factor, letting them know, hey, you can. There's no access here for the ramp, so you need to come back around. So drop off. Again, similar situation. Drop off. If it's a person could be wandering and dropping off. So whenever we have these return curbs, if there are any place where it's reversible surface, need to be soft surface, landscape surface, and we saw that in the previous standard drawing that we referenced. Another drop-off. Obviously, this is not a contractor issue. So as been constructed, we find here this brick, how it's been in the back of the ramp, this drop off. And the solution here could be go back room instead of taking, if the ramp all meet condition, maybe just come back and remove the brick and bring that level so it there would be no drop off. And that because it's not non-traversable surface, it will be good to have that landscape, sockscape. The second category here, utilities, junction box within the ramp limits. And we talk about the ramp limits, proximity limits. Ramp with ramp run, large cracks, ramp does not end at new concrete and ends at. So we look at this example here, for example, see, it seems, and we can't tell what's the whole story, but it seems the contractor here, let me just do this, seems the contractor, another contractor, the designer was trying to avoid work on those detector loops and this one, so they stopped the work here, and but they end up with the more errors, and they end up with failed ramp because you have a break into the ramp, you have utilities in here, you have additional cracking happening in the ramp. Quite often we see cracking happening around these utility box, so avoid utility box if you can from the ramps or from the ramp runs or the ramp elements. That's the better solution rather, and it's on the long run better than preventive measures rather than having crack as you can. If you cannot, there are about the expansion joints. We looked at that in the specs and special provision that we mentioned, and how we place them and so forth, so to prevent such cracking. The other challenge comes with those junction box are their lids. They don't necessarily always come flush as you put them, and they end up with that, which creates a hazard and then it becomes the slope and all the criteria doesn't fit anymore. Because if you put the ramp here, you will not on this location, and you will end up with different sloping and so forth. So that won't work. So if you end up with having the situation, these lids, they need to be strictly flush, and they are meeting the slope, all the requirements as in an ADA. So just the existence of this junction box or bolts does not mean they could have different standard than the ramp. They still have to meet all the ramp standards. Other reasons for failure is inlet within the ramp, the pedestrian path, even outside the ramp, but in the path of it, that's failure, that's no. So remember of the construction inspection form, the curb ramp inspection form, inlet crossing, that's definitely yes, and that would be a fail. So if you can avoid this, that would be better. Of course, the designer should move it up here. If there's that the flow, if that's a low point, that's why they're trying to do it. We could shift the low point somewhere here, and you install it here away from the ramps. That's a better solution. So this should be identified during design plan and review. And as the contractor submitting the drawings, notice, hey, I got the ramp, I got this is not going to meet. So that's the time 21 days before the pre-placement conference where you bring these issues and talk about it too. Manhole within a ramp limit must be set correct slope again. Those manhole, we try to avoid them. If we cannot avoid them, they need to meet again the slopes in both directions. They need to be flush. They shouldn't be causing any differential slope. Any minor differential slope, any minor misalignment would create differential slope, and that will not pass. Again, the correct slopes need to be in both direction, cross slope and longitudinal slope. And in this case here, 5.3, and it's creating differential slope between the two, and which causing to have inconsistent curb ramp run. Just the installation of this ended up causing this, having this defect, which you then end up failing this ramp. Transitional panels. Transitional panels are, we talked about in the standard drawing, and how they need to, this is a transition. So you're connecting ramp. Here's the new ramp run. Here's the existing sidewalk. And this is your transition panel that we try to connect the ramp to the existing sidewalk. So the cross slope may work 0.5% per foot for the slope at the top of the ramp here should be 2%. It could warp 0.5% per foot to match the back of the slope here. And I can't read the slopes here, but probably the slope here and slope here, it's not the same. Remember, x2 should equal x1, otherwise it will be inconsistent ramp run. Again, transition panel. I'm not sure. I mean, if this transition panel trying to connect to the slope here, obviously created a differential slope, significant differential slope, 18.1 and 0.8. So that is a huge difference. So you need to have probably extending this a little bit more to solve this issue. And I'm not sure if this means a 3% in this direction. If this is slope here coming into the ramp, here should be 2%. So the transition should be 0.5% per foot. So if this is here 3%, that's definitely also failing, warping too fast. Asphalt patching, I'm not sure if I went a little bit off the presentation today. I'm not sure if Adam or Landon covered this. But there are new criteria coming up from ODOT that regarding the asphalt patching, regarding the slope of it, and I understand it will be added to the new inspection forms, is that the slope of the patch across the slope should not be worse than the existing roadway slope. So as you're as you're pouring the asphalt to build the new ramp, you construct the ramp, and you come back with a patch here, and then you slope it up and too fast, worse than the existing condition, it will fail. It should not be more than 5%, and should not be worse than the existing slope of the roadway slope across the slope. So make sure that as contractor and inspector check this one out. And I know this sometimes may be tricky. Because the ramp may be already built based per plan elevation, but then you come back here, you call it, and if you're not checking this, it will fail. So maybe some additional things need to be taken care of. But pay attention to that. And then additionally here, the asphalt patching, the lip that's causing it, that's also another failure. Should be no lip here. So it seemed like we have here slope of 13.1, which is definitely failing. It's making it worse than the existing here, so that's failed. 6.1. We talk about the 5%, which is failing. And here, the patch is creating the slip. Should be flush. Should be no lips around. All around within the proximity limit. Another lip. Should not happen here. Dimension. So we talked about the design, especially when it comes to the linear dimensions, turning space, the minimum, the design 4.5 by 4.5, and contractor could go as a tolerance 4 by 4 for ADA failure. So make sure that contractor, first of all, there's 6 inches is quite a bit of tolerance, but if you go less than 4, then they got a different problem. And obviously here there is posts that causing this, but you need to be checking this one out before you form it and make it before pouring it too. So check this one out. Here it's obviously, here's a 4-foot mark. And this is right here, so that is a failure, and it's written here 3.9, so that's fail. Turning space 4 by 5. We talked about turning space. If we have a back of ramp obstruction, the 5 feet should be this way, the 4 feet should be this way, and obviously here, if you look, this measurement here is about here, and you see it here. 3.9, so that's a failure. So definitely that's need to, there's no reason for that. It's just a matter of forming and a matter of finishing. Another dimension issues is the clear space. When designers, quite often, I myself was in that position sometimes, you check, okay, I'm going to come from the face of the pole here. I have my 4 feet, but once you come back and you look at the base, you look at the configuration of the base, that would give you less dimension, so the clear space comes from here to here, not from the face. So make sure you check on this, designers, and that allows more time. So in this case, it was 3.7 inches, while it's supposed to be 4 feet. This one, it seems, was okay before. And if you look from the back of the curb all the way here, it seemed like we were able to meet the force. Probably the local agency or the agency who had jurisdiction of the road came and put this plate, put the sign, and that becomes now the new, because there's a lip here that's causing this restricting of the clear width. A better solution would have been if just this post was drilled instead of just putting this plate, and that would still have met the clear width requirement. I just thought that they needed a little bit here, and they would made it. Dimensions again, if you have a back of frame obstruction, this length should be 5 feet. And here you can see we are about 4 feet 7 inches. So that is feels too sad that you get all this concrete and poured and you have to remove it. Just not paying attention that, okay, I need to get to this exactly. But that's why check forms and check drawings before you get there. Similarly here, back of obstructions, back of ramp obstructions, 4.4 should have been 5 feet. Not sure if it's a design or construction, but that's a failure. We're not saying, hey, it's contractor issue. It's just we're saying that these are type of the examples that failing these ramps. One thing I liked about this picture, how there is here dropout, but they have this protection, and you see that part of the standard drawing. So there is even this dropout here. So there is traversable surface, but it's protected. So let's make around that. Truncated dome installation. That's a typical common reason for failure. The first one, stacking, is not acceptable anymore. So these should be straight all the way from here. If this is more than 5 feet, then these need to be lined up this way for the standard drawing. And it's obviously here is 12 feet. So that this installation is not acceptable anymore. Just removal of this, making radial linear in this direction, truncated dome would work better. The 2-inch gap, it's also common. The 2-inch gap, it should not be from the back of the curb more than, and it shouldn't be, if there's a tangent, I don't understand why we would have that. I could understand if it's in a radius. On a tangent, it just makes sense just to bring the truncated dome all the way here, and you don't have, because it end up having trouble with this maintenance of this one becomes maybe an issue pop up or something like that, because it becomes or a lip between the truncated dome and this. Pushing this all the way here is a lot better installation. This installation, it's the raised island, and it's a cut through. Obviously, we don't need a too truncated dome because we need to have a 2 feet minimum between the two, and also not sure why we put it this way, but yeah, this is one where we don't. If we don't have this, if they are less than 6 feet, we eliminate one. Another gap, the 3-inch gap, truncated dome. Slope of the truncated dome. So the first truncated dome part, category of failure is the dimension, the 2-inch, or the incorrect installation when we have them this way, or the stacking. Then the second one is slope. So if you end up with trying to press it while the concrete is wet and others, so you end up with probably more than 2% slope. So be careful, because that part is still of the ramp, and that 2.3% is failure here. So it should be continuous, should be the same slope, and it definitely should be less than 2%. Again, here 2.8% slope on the truncated dome. Probably the concrete was fine, I'm not sure, but it seems like this is one that failed it. The 2% we're talking about, if it's a parallel ramp like this one. So if it's parallel ramp, less than 2% is expected. If you are on a perpendicular ramp, is 8.3 or 7.5 the designer. So just I want to make sure we understand. On a parallel ramp, truncated dome installation and truncated should be still meet the slope per ramp. The cross slope should be 2% no matter what. Oh well, depending on the intersection type. For parallel ramp should be 2.3. For the perpendicular ramp could be according to the intersection type for the cross slope. Concrete finishing small area. So it's quite often we hear, hey, it's just a small area. We need to take that ramp. I think it doesn't matter, a small area. It's just a finishing. Remember when we saw that, how the contractor checking slope as they're moving up? Quite a bit of these failures happening during the finishing. So pay attention during the finishing and check slope as you're going. Here it seems like meeting, except here, this area where it's failed, and that failed the ramp. Again, concrete finishing, slope here. Let's see if I can read it. It seems 2.4 or 2.3 on a parallel ramp where it should be 2%. There is no reason it. Quite what we saw in the field, sometimes you're coming from here and transitioning instead of transitioning the slope in this area, instead of just cutting it here, and then that should be 2%. Or a ball shape around here in the back of the ramp. So the finishers, as they're finishing, they're creating that ball and creating that differential slope within the turning space. Okay, concrete finish for a small area. This area that will just fail the 2.4 of the ramp run. So the ramp run coming this way, and only one area that caused that failure. Finishing workmanship. So when you connect new concrete to old concrete, a better socket, a better work, instead of leaving this large gap or differential lip. Similarly here. Crack in new concrete. Again, these creating gaps and horizontal gap. Shouldn't be, remember the horizontal gap based on the RD 722, no more than half an inch in width, and vertically should be 0 flush. Curb running slope, the max is 8.3. Unless you are on a directional curve, should be less than 5%. So here a curb ramp, when you average them, curb running slope seems average 10.6. You have here 14, 11, and 6. The average to 10. That is fail. And I can see you have another reason to fail here when you have this more than 2 inch You have two. Curb within the opening of the ramp. I'm drawing blank on this. I think this is for the slope. No, the slope seems good. Adam, do you know what this mean, curb within the opening of the ramp? I'm going blank on this.
Yeah, this one, the average is greater than 8.3%. It just doesn't write it on here.
Okay, thank you. So yeah, if we probably averaging these three number, 6.8, 9.3, yeah, it seems like it will be more than 8.3. Thank you, Adam. The opposite curb running slope, you look at the direction of the flow, should be the curb running slope when you're measuring it should be perpendicular to the path, and it should not. And oh, I see. Yeah. And the other thing here, it seems like you're directing the water to be into. Yeah, the curb running slope should be in this direction, not into this. Is that correct, Adam? Also, I'm going blank on this.
No, what's happening here is the top of the curb is sloping towards the ramp. And so the low point is not at the flow line. The low point is at the back of the curb. So that's what's wrong.
Okay, right here.
Yeah, that's the low point, and it should be at the, where the face of curb line extended would be.
Yeah, it should be like 6 inches here. That's the curve. Yeah.
Yep.
Thank you.
You're welcome.
Similar situation here. Area between ramp runs. We talked about the 757 when we have RD 757 when we have two ramps. The distance between the two ramp from the back should be a minimum of 5 feet, and the distance between the ramp, top of the ramp run, and the next driveway should be a minimum of 5 feet. And so in this case, it seems it's 3 feet, and that's a failure here. And if this less than 5 feet, it would definitely be a failure. Again, area between ramp runs. So here there is no area at all from one ramp to another ramp. One going this way, another this way, should be a minimum of 5 feet. And again, driveway and ramp run. So the ramp run right here, and the driveway ramp is right here. And this area should be, no, it seems like this is a ramp here, what they're measuring it from. And that is 2.5, 2.8, 2.6, 2.7 feet. And that's where it's failing. I'm not sure why the ramp here should be right here. The distance should be measured from the top of the ramp if this is a flatter area. I would probably say if the ramp's not starting from here where I see the joint, if this going this way, just make this one a flatter area, and that would fix the problem if it's more than 5 feet. Flares should be, slope should be less than 10%. I know there is also some new changes. If it's traversable, we were before, earlier in the training, we were distinguishing between traversable sidewalk coming to the rail or none. So what we were saying, if it's non-traversable, the flare slope is not criteria for failure. That was corrected, and they said no, it should be less than 10%, whether it's traversable or not. And so pay attention to that. Currently, I think the inspection form, if you uncheck traversable but you put 11, it will not fail it. But if you put traversable and you put 11, it will fail it. So check this one out. So the flare slope should be less than 10%. And here is CM 14.1. And remember, you measure the flare slope within the 2 feet, which is like width of a truncated dome. %, and that will take care of it. So we're way ahead of schedule. Any questions? Anything from the group? Okay, I think if there are no questions on the, I'll turn it to Lindsay. Lindsay, if you want to take from here, finish today's presentation.
Yeah, I think we've got Adam next doing celebration.
Oh.
So if you want to go ahead and pass the presentation to him.
Oh, sure. Thank you.
Okay.
Adam, would you be able to take it from me? I'm having challenges moving that ball toward you.
Yeah, give me just like 20 seconds.
Okay.
I got it. I'll move it.
Thank you.
Okay. So I'm going to need everyone to lock their screen on me. So if you don't know how to do that, I'll present my screen here. I can't see myself when I'm sharing. Never mind.
Adam, if you go to share up at the top, there's a little tab that says share, and then you go share my note, and it'll show just your WebEx note.
Oh, okay.
See that?
I am sharing WebEx now?
Yes.
Okay. But I can't see it on my screen.
Well, I think.
Like, can you guys see just like my email browser right now? Or is it?
I'm seeing.
I think as long as he's talking, as long as he's the only one talking, he should be the one showing up anyway. So
I think so too, as long as you're not presenting.
Yeah.
Okay. All right. Cool. Well, as long as everyone can see me. Here we go. I'm going to do a live demonstration on how to calibrate Gen 2 Smart Tool level. So this is the Gen 2 level. First of all, I'm calibrating it on just a postal box just to get it at the right height for my camera. We would obviously never do this in the field. When we're calibrating levels in the field, what the level is doing is comparing two measurements and taking the average. And so the most important part of the level calibration is to get it back in the same spot every time. And so I'm going to line it up with the edge of the box and make sure that I'm getting it back to that same spot every movement. So to begin the calibration, we press and hold the middle button on the level, and it's going to say Cal 1 and flash. And now the screen is flashing. We've already taken the first measurement, and so it wants its pair. So we're going to flip it 180 in the same spot. And I generally wait for it to flash the same number 3 times in a row to ensure that it has settled on a number. It will not stop flashing, though, until you push that middle button. And then it takes the second measurement. And now you can see the screen is no longer flashing. So I've taken the second measurement. So now what we're going to do is we're going to flip it upside down. And we're going to do the same 2 steps. So wait for the level to settle on a number. And then press and hold the middle button. And it'll say Cal 1 and start to flash. We're going to flip it 180 in the same spot. And once it flashes the same number 3 times, I'm going to press that middle button. And now we have done our horizontal calibration. So those are the first 4 steps of the level calibration. So the next part, we're going to go to a wall and use a wall for the vertical calibration. Again, I'm going to use this box for ease of viewing, but we would never do this in the field. And for the first 2 measurements, we're going to start with the bubble on the bottom. And if you're using the 6-inch Smart Tool level, that's going to be the screen on the bottom. So it'll be like that. And so we'll press and hold the middle button, and it'll start to flash. And now we're going to twist it 180. So the bubble is still on the bottom. A lot of people mess up that step. It's a twist 180 to get the second measurement once the screen is flashing. And then once it flashes the same number 3 times, then you press the middle button, and it'll say Cal 2, and it'll stop flashing. Now what we're going to do is we're going to flip it so that the bubble is on top and do the same 2 steps for the rest of the vertical calibration. So we're going to wait for it to settle on a number, press and hold the middle button, and it'll say Cal 1, and it'll begin to flash. And now we're going to twist it 180 degrees, just like that. And then once it flashes the same number 3 times in a row, then I'm going to go ahead and press that middle button, and it'll stop flashing. At this point, the level should be vertically, or should be calibrated completely. So what we're going to do to ensure that it is calibrated correctly is we're going to check it against itself. So it should read the same facing both directions. So currently it's showing 0.5% sloping down that way. And I'm going to twist it 180 degrees in the same location. And it should still be showing 0.5% sloping that way. And by some miracle, it is showing exactly 0.5%. As you can see, I locked the screen. So you can see, right now you can see there's a screen lock function on the level, so it won't change. And that's what those arrows flashing on the side mean. So if you find that all of your ramps are passing at the same exact percentage slope, you might be locked on your level. But this level is calibrated. If you finish the calibration steps and the level is not reading the same way when you flip it 180 degrees, then the level is calibrated incorrectly. Generally, we accept the level as calibrated if it's within 0.1% of itself. So if it read 0.5 that way, and I flipped it and it read 0.4, I would have started the inspection anyways. And with that, we're accepting that the level might be up to 0.1% off from true. And so anytime that we're inspecting something and it's failing at 2.1% or 8.4%, really close, we always want to get the level in that same exact spot and flip it 180 to make sure that it really is. If you flip it 180 and it's reading 8.3 the other direction, then that's when you get everyone together and calibrate the level in front of everyone and find that same exact spot and make sure that it really is failing. So we don't want to be failing ramps that are actually passing. All right, that is the Gen 2 level calibration. That is the same calibration procedure as for the 6-inch Smart Tool level. And I'm going to show you the Gen 3 level calibration right now as well. So we have handy dandy Gen 3 level. Looks pretty similar except for the button layout is different. And it is slightly more waterproof. And so there's actually like a little casing inside the battery casing that protects it from water, slightly better than the Gen 2 did, but it's not perfect. So we're going to do, for this one, you can just press and hold the center button and it will start calibrating itself. And so it hasn't taken that first measurement yet, but it'll beep at me. You might be able to hear it over the speakers. It just beeped. Now I'll flip it 180, and it's also showing 2 now. That means it wants the second measurement. So flip it 180, and once it picks a number, it'll beep at me again, which it just did. And now the screen is flipped upside down, and it's flashing the number 3. So that means it wants the third measurement, which is this one here, upside down. The screen is always going to be flashing the word up, and you should be able to read it with the level facing the direction it should be in. So it flips for position 3 and 4. It also reads the word up for the vertical calibration, but it's working with very limited pixels. And so I don't know how well you can all see that over the screen, but it is flashing up. And so obviously this is not a very accurate vertical surface to calibrate against, but it is best I can do for now. Notice that the bubble is up for the first measurement on this one, whereas before we did the bubble down for the first measurements. It's not going to calibrate for me because holding it still enough. Maybe if I just let go of it. There it goes. All right, now it's flashing the number 6. So I'm going to twist it 180 degrees. Sweet. And now we're going to flip it so that the bubble is on the bottom for the last 2 measurements. So bubble on screen is down for the last 2 measurements. And it'll beep at me. Now it's flashing the number 8. That means it wants the last position. So last position. And generally we use door frames or walls. When we're out in the field, signal boxes, light poles, sturdy objects out in the field are really good. Electric boxes are the best, but stop signs are really terrible for vertical. And sometimes sidewalk can be bad. So you're going to want to make sure that you mark out where you're doing it on the sidewalk with some soapstone or crayon so you can get it back into the same exact spot every time. And they agree with each other. So there we go. We did it. Somehow. With the postal box. All right. Does anyone have any questions about the calibration procedures or the levels in general? All right, I'm not seeing anything coming through. So that concludes the level calibration. You do all have a handout, attachment 6 in your handouts. We'll have the level calibration steps. So if you forget how to do it, you can find it there in attachment 6. And there is a video on YouTube from the manufacturer, smart tool levels, that will also walk you through the calibration process. All right. Sounds like it's time for questions. We also don't have any coming in, so, and we asked for some earlier. So we may just conclude the training right now. Lindsay or Riyadh or Landon, was there anything that you wanted to add?
No, I think from my end, this is Riyadh. I think we covered all. I think I would just want to add one thing is in the, I'm not sure if it's covered by Landon because I moved a little bit out. When you're filling the inspection forms, and they are built into the tolerance for the design criteria, for the design exceptions. So if you have a design exception, you click the DE button, it will ask you for, prompt you for the design control number. If you put the design control number, it will prompt you for the design value. And if the design value, let's say 2.1 on the cross slope, and if you put 2.6, it will pass it because the tolerance is 0.5%. If you put 2.7, it will fail. I'm not sure if that was covered during today or not.
Yeah, Landon did cover the
okay, great.
That during the form.
Great, thank you, Landon. So.
Yep. Nothing from my end. I think we pretty much covered it. I want to thank everyone for being patient. I'm sure staring at a computer screen, this wasn't how you wanted to spend your day, but we appreciate it.
I've got one really important point of business before everyone logs off. If you did not type your name into the chat earlier, if you missed that part of the training, there were some people that didn't type their name into the chat. So this would be the time to do it so that you are on the logs for taking this training.
Yeah, thanks for adding that, Adam, and thanks everyone just for bearing with us through this first time we've done this kind of training virtually. And I know there's some going through that and technical issues. So thanks everyone for just being patient and sticking with us.
See you later, guys.
Thank you.
Bye.
Hey, this was James. I was going about the form missing.
Oh yeah. Where's that?
Do we want to just let him share?
Yeah, I'm wondering if you shouldn't. Yeah, there's a button in the middle of your icons there. So kind of a square with an arrow pointing up.
Yeah.
If you use that, you can share your screen, and if you can pull up what you have, I'd be curious just to take a look at it.
Someone's probably gonna have to pass him the ball.
Oh, yeah. Hang on. There you go.
You can see my screen.
Just thinking about it.
Hey guys, I'm gonna have to hop off. I have another meeting starting right now.
Okay,
thanks, Al.
All right.
Yeah, thanks.
Thank you.
Yeah, James is just showing up black on our end right now.
Let me see. Oh, hang on. Let me see. How about now?
Okay, yeah, we're seeing it now.
You see your email now.
I got two screens going. Didn't know I was in the wrong screen. So if I click on attachment 4.
Yeah.
But we're seeing your emails now. Okay, now it's gone good.
Opening.
That's slow.
It's
Yeah.
taking its time to load here.
It's finally loaded for me, so. You guys see it yet?
No, it's all gray right now.
Okay.
Ah, there we go.
Oh, there's a little button at the top said share, stop. We use Teams, MS Teams.
Right.
So it had the 7. I'll just scroll a little fast here. It had the 4, and it had the first. Just had this page here, and then that, and that was the end.
So he's missing 19 through 22, the new form, and then there was 2 other additional Exhibit C.
Well, this looks like the old form, though.
Yeah.
That's weird.
Yeah, that is the old form.
And these were right off the email about money.
Yeah. Okay. Well, I will follow up with the new form and I'll resend that attachment. I don't think this is the one that I had sent, but I know we were kind of compiling stuff last week. But yeah, this form is turned into 2 forms, and then there's also an exhibit that kind of goes with it. It's kind of informational. So
Okay. And then
I should have everybody's email, so I should be able to follow up with that. So I apologize that that's not
Okay.
right. But yeah,
And the presentation, it wasn't supposed to be the whole PowerPoint, was it? Or the whole 200 some slide? This just.
No, that one that's actually I've renamed. That was one that was the level placement guide. That should have been
Yeah.
that one.
Yeah, that's all it was. Yeah, it just showed all the. Okay.
And the top one should have been the one with all of the slides in it. Yeah.
Oh, okay. Duh, gotcha. Okay.
Yeah.
Oh,
Okay.
Okay.
All right. Well, good to know. Thank you for letting us know that. I'll follow up and make sure people get the right ones.
You bet. All right.
And I don't know if they're fully available. They were being loaded onto ODOT's website, so they may be available directly from the forms page on the website. I don't know if they've gone live or not. They probably should be by now. I got them about 2 weeks ago, so they should be live. But I'll send them out regardless.
Sure.
No.
Okay.
Okay. Well, thank you very much.
Thank you.
All right.
Thanks,
Okay.
Chris. I'm gonna go ahead
Thank you
and
all.
close out the meeting here, unless you guys have any follow-up review.
Do
No.
we need to do any briefing, any good listener or something, or you guys feel good about it?
I would say if you could follow up offline with me on anything that you noticed today, I'll have a chance tomorrow morning to make any changes before Mondays. I need to send that out probably tomorrow morning so they can distribute those links to the next class. But if there's anything that was significant that you think needs to be updated, I can do that tomorrow morning.
No,
Okay,
I thought it's pretty good.
sounds good.
Thank you all.
Okay. All right. Thank you.
Bye bye.
Hi, guys.
Bye.
Yep.